Hello, this is the next question that is about the special theory of relativity. And you can see on my screen the space time diagram. This is the CT axis, and this is the X axis for the inertial frame of reference, or we can say for the S frame of reference. Okay, now these are the two events, P and Q, that occurred at the same time independent of the frame of reference, which means that let me show you this thing in the diagram, right? Because we have to later on prove that, first of all, what is a invariant quantity, what is the meaning of that, and what is the value of this thing. So this diagram that I'm going to show you is going to be very helpful for you, right? So students, let's say this is our one frame of reference, and let's call it S frame of reference, right? And this is a S prime frame of reference which is moving, right? Now when these two events occurred, right, let's assume that these two events are uh, the emission of photon. Okay, so something happened here and something happened here at these 2 points, and this is an observer here at this point. Okay, so what will happen now, the photon will travel from the one end, and the same photon, I mean the another photon will travel from the other end, right? Now when the photons are traveling and they are going to the observer is looking, the light is coming from the right and the left. So now this is an event, let's say this is an event P and this is an event Q. Okay, now what is the meaning of the invariant quantity? It means that when an observer in the spaceship will measure the speed of light according to the S frame of reference, right? So the speed of light will be approximately 3 multiplied by 10 to the power 8 meter per second, right? Don't forget, it is not that frame of it's a separate frame of reference, right? It's a S prime frame of reference. And what about these two observer, these two photons? According to this observer, if this observer will measure the speed of light, it will be also same exactly speed of light. It means that speed of light does not change irrespective of in what frame of reference you are. Okay, even just imagine if there's another rocket, if in another spaceship, and another observer is trying to measure the speed of light, according to that observer also the speed of light is not going to change. Okay, now to keep this quantity invariant, the other quantities vary. Okay, understand, remember that if you have to keep this quantity invariant, then the other quantities like the distance and the time, they will adjust themselves in such a way that this quantity will not change. For this reason, what happens, for this observer, the time calculated, the time t prime, will not be equal to the time that this observer will measure. Okay, so their times will have a delay, their times will have a difference, not the speed. Okay, this is a meaning of invariant. So that's why we always say, what is the meaning of invariant quantity? It means that which is independent of frame of reference. Okay, and speed of light is a wonderful example of that. Okay, and here you can see what the mark scheme says, does not depend independent of frame of reference. Okay, now let's calculate this delta S square. So I have explained you the one thing, but we can prove it mathematically, because the quantity that is invariant, just like a speed of light, for this delta S square never changes. Means delta S square is basically equals to the C delta T square minus X square. All right, if any quantity will be invariant, then you can prove this thing by calculating this side. If this will be equals to the C delta T prime square minus delta X prime square, means that if in the same space-time diagram, if I draw the uh, space-time diagram for the S prime frame of reference, the other frame of reference, and if I find their quantities, their values, then they should be equal to each other, then we can prove that it is invariant. Okay, now what will be the value of delta S square? By looking this space-time diagram, so that is easy. As you can see that what is the difference between, because the value that I will calculate from here, that must give me the delta x, okay, and that is 5 minus 2, that is 3, okay, 3 meter. And this quantity, right, which is only 1 unit, so that is 1 meter, this must be c delta t. Clear? So if I want to measure delta s square, so we can do it by taking square 1 minus 3 square, and that will be equals to 1 minus 9 minus 8 meter square. So my point is that you can prove that a quantity is invariant if you get negative 8 meter square again by using c delta t value and delta x value, right? Right now it is not possible because I have not drawn the c delta t prime axis and delta x prime axis. We will draw it later. Okay, students, so now the next question, they say event P and Q occur simultaneously in an inertial frame of reference. S prime and clock of S and S prime are synchronized, okay, which means that the value of X and X prime is equal to 0, all right, which means that you must start it from the origin, okay, we must start it from origin, this axis, right, whatever the line is, we don't know the angle, okay. Now sketch on the diagram the coordinate axis of this frame, the coordinates of the frame, reference frame S prime, okay. Now the problem is that many students will confuse here and they will think we are not given the velocity, because if you are given the velocity of this spaceship, from that velocity you can find out the angle, and from that angle you may draw the frame of reference, okay, the axis, okay. But we have a very strong clue that was already given in the beginning of the question, right? You remember what has been told us, that this P and Q event occur at the same time in both frame of references, okay. This P event P and P event Q occurred at the same time in the S frame of reference as well as in S prime. It means that, don't you think that the delta t value and delta prime value is actually same, right? Because P and Q happened at same time, all right, okay. But the next problem is that now we don't know what line should I draw, because whatever line I draw, I will get the same point, okay, because if the two events are happening at the same time, and to find the value of delta c delta t prime value, okay, please listen me carefully, I want to know the what is the value of c delta t prime, because c delta t is equal to c delta t prime, these both are equal because they happen at the same time. Now to find that, we always draw a line parallel to x prime axis. I hope you remember it, okay. So what I will do, I will draw a parallel line which will connect these two events P and Q like this, okay, and I will get some point on the c delta t prime, which shows us that the event P and event Q occurred at the same time, okay. I hope you understand. So what is the concept? Okay, concept is that I will draw a line like this, let's say like this dotted line. You see this dotted line is joining P and Q, okay, because that is happening at the same time. Now so now you can see that this angle is 19 degrees, okay. So if I start it from the origin, okay, so it is clearly giving us what? Yes, you thought correct, it's x prime, okay. And now you can see that this dotted line and this line are parallel, and if it is 19 degrees from here, okay, so then I must draw 19 degrees from the y-axis, okay, which means it will make 71 degrees from the x-axis. So this is, dear students, c delta t prime axis, okay. And if I now join them, so dear students, as you see, both events occurred at this time, Okay, by the way, we don't know this value, but you can understand that they are happening at the same time. Okay, so these are the coordinates axis. Okay, so we have solved this question. Now the next question is determine the speed of s prime. Okay, so to find the speed of s prime, first you need to draw the axis, and we have already drawn it. Now what you are waiting for, you can take a point here. Okay, let's say you can take this point. Okay, so you can see that this is a kind of a right angle triangle. Okay, this is a triangle. All right, this is angle theta. This value is 1 and this value is 3. Okay, so we know that the tan theta is, so students, this is a theta. This is 1 meter according to s, because we have to find relative to s. According to the person who is in the s frame of reference, what he is thinking, that the speed of the spaceship, right? According to this, we are going to calculate that thing. Okay, so this is 3 meter, so tan theta is equals to opposite over adjacent, right? So that is 1 over 3, and at the same time, it is equals to v over c. Tan theta is equal to v over c. So v is a speed according to the observer in s frame of reference. The speed of spaceship is c over 3, right? So which means 1 over 3 times speed of light. Okay, so this is our answer for this question. I hope you understand all of the explanation. Thank you.